My fabulous chemistry faithful. Last video, number 7, electrolytic cells, the last cell. This is just so we can formally contrast and understand the difference between the two cells. So we need to know what's going on here. So these are electrolytic cells. These direct current sources or batteries up top. There's a positive and negative terminal. Notice again, there are two electrodes, but they are in one container. They're not in two different containers. And so we use this stuff for these two examples here for electroplating, which is taking metal and making it go over the top of another metal. So that happens sometimes with cheaper silverware or cheaper jewelry. If you get like a gold plated earrings, that's just taking a lesser valued metal and then coating the outside of it with gold, which means it's a lot less gold. Electrolysis of water is another process. It's taking water and breaking it into its two gases. And hydrogen gas and oxygen gas are valuable things. They're both fuel sources, and hey, we breathe oxygen, right? So we need that stuff too. So here's just a quick breakdown. I believe if you'll see what switches is the cathode was positive before and the anode was negative, and that's what switches. It still goes anode to cathode. It still flows from A to C, but I believe what happens is the charges on the cathode switch. There's always something that switches, and I always got to remember what it is when we get into this unit. So by definition, electrolytic cell uses electricity. It's a non-spontaneous reaction. We learned how to figure that out in video 5, spontaneous versus non-spontaneous. So I need electricity to make this go. So if you see any kind of a battery instead of a voltmeter or a resistor, that's your clue. A voltaic cell is going to have something that's going to use the energy. So like a voltmeter would measure it, or it could have a fan, or it could have a refrigerator, right? An electrolytic cell is going to have a battery instead. Now it flows backwards and what flows backwards is it flows from positive to negative instead of negative to positive. What switches is the signs. Still flows A to C, so I don't want you to think that it flows from C to A. Okay. The purpose of the battery is the source of power. It's the one that gives the reaction the ability to overcome the fact that it is a non-spontaneous reaction. So a lot of times those questions show up. You're pretty much either going to get what is the function of a salt bridge, or you're going to get what is the purpose of the power source in an electrolytic cell. Those are generally two questions that show up about these kinds of things. So it's the power source. So all you got to say is it's the power source. I'm going to give you a few examples in real life of what we use for these things. Now I'm going to get on my way and call this a unit for you guys. Electrolysis of water, making some good things. H2 is a great fuel source. O2, well, we all need that, right? And it's also can be used for fuel. Covering reactive metal, so this is electroplating. So we talked about it real quick. We can copper plate stuff. We can gold plate stuff. You can take, you just got to get the chemistry right within what's in the solution and have the metal in ion form present in that solution, and you can make it go onto the other metal and coat one kind of metal with another kind of metal. Happens, and then sorry, that was a stupid joke I remember from last year that caught me off guard. I added some sound because the most common use for these things is whenever you guys plug in your phones to have them charged. To charge the battery is using a power source coming from the wall, electricity, to recharge the battery and to sort of, store electrons in there for you so you can use your phone to either, TikTok or play videos or whatever you're going to do. So there you go. With that, we are done with the unit. So keep working. Let's get on to Castle and see what the next unit brings. 2.